Hello, researchers. Welcome back. So I wanted to do a little math review. The only math you'll need to know for this course is basic, like high school math. But for some of us, it's been a really long time since we were in high school, and I count myself among those. And so I just wanted to review some things. So just some basic things that are going to help us as we're talking about statistics. Okay, and we're going to use M&Ms. And I was like, I better go ahead and do this video because I kept buying M&Ms with the intent of doing this video and then just eating the M&Ms. So here's my collection of M&Ms. One bag of M&Ms. Mostly a lot of orange and blue, some yellow, some red, a few brown, and just one green M&M for a total of 55 M&Ms in that bag. Okay, so let me get my whiteboard and bring it forward. Let's talk about different forms that we can write the amount of M&Ms. Okay, so this is our M&M math review. So we're going to identify the M&Ms by color. And usually the first variable on your list is some kind of identification variable. And so you might see it, ooh, that's too light. The first column in your data files might be ID. That's too late too. ID, and that just stands for identifying variable. Okay, so the number, I'll just write the number of M&Ms here. 19 orange, 17 blue, 7 yellow, 6 red, 5 brown, and 1 green. Okay. Another word that you'll see in statistical programs for just a number is the word count, right? So I counted the M&Ms to figure out how much there were. And so you might see count, okay, instead of number, because actually they're all numbers, but they're just forms, different forms of the number. Okay, so a fraction, as you recall, would be the count of that particular color out of the total, and there were 55 total M&Ms. So for orange, it's 19 out of 55, blue, 17 out of 55, yellow, 7 over 55, red, 6 over 55, brown, 5 out of 55, and green, 1 out of 55. And every time I've done this lesson, I've made a mistake somewhere along the way. So if you see an error, please post to our discussion board and say, Dr. Campoli, you made a mistake. Okay. Okay, so the decimal associated with that fraction, we divide the numerator by the denominator, or the top number by the bottom number. So for orange, I got my calculator, 19 divided by 55 equals 0.345, and it goes on 45454545. I'll put a bar over that to show that repeats. Okay, and then 17 divided by 55. Okay, 0.309, and this goes 090909. 55 must be one of those fun numbers that you get these long decimals when you divide by. Okay, and then 7 divided by 55 equals point. Is that called irrational numbers? One of you math majors, help me out. 0.12727, and it keeps going. Okay, on. And then 6 divided by 55 equals 0.1090909. Okay. 5 divided by 55 is 0.090909, and so on. And then 1 divided by, let me clear this. 1 divided by 55 is 0.0181818, and so on. Okay. All right. So we've gone from the identification of the M&Ms by color, to a count of them, to a fraction that shows them, to a decimal. The way we change the decimal to a percent is we're going to slide our decimal place over 2 places, tenths, hundredths. Okay. So this is 34.5%. 1, 2. This is 30.9%. This is 12.7%. This is 10.9%. And this, the zero we won't write, 9 point, because this 9 is greater than 5, we're going to round this up to 1, 9.1% there in the hundredths place. And 1.8%. Can you see all that? Yes. Okay. So we have a fraction. When we express it as a decimal, often that's talked about as the proportion. Okay, and the proportion is out of 1. Okay, so it was 1 bag of M&Ms. 1 bag. Here, let me write total here. Okay, another word for total is sum. Okay, because we add everything together, we sum everything in order to get a total. For the count, the total number of M&Ms was 55 M&Ms. For a fraction, the total is going to be 55 out of 55, or that's 1 bag, right? 1 bag of M&Ms. Okay, see that? Let me put a comma there. If you added all these together, they would equal 1. Because again, we have 1 bag of M&Ms. And these are the proportions. The proportion of orange M&Ms, for example, is 0.345. The proportion of blue is 0.309, and so on. That's the proportion of blue M&Ms in the bag. And then for percentage, our total is going to total to 100%. Okay? It might be a little off due to rounding. but for percentages, we total to 100. For proportions, we total to 1. Okay, for fractions, the numerator will be the same as the denominator, which will be 1. And then the total for the count, we don't know. It depends on what our data is, right? And then the number of colors, okay, the number of different colors that we're analyzing are 1, 2, 3, 4, 5, 6. I would say that in this data set, N equals 6. The colors correspond to our participants, and we had 6 participants and making our little data file here. So N, usually we use a capital N for the total number of participants in a research study. And we had 6 colors participating, so N equals 6. All right, so that's our little math review. Yeah, okay. See you next time. Bye-bye.